Then we move on. So in this section, I want to go through some kind of a general overview of main biofuel production processes, and just I will not go into details of these processes because in the coming lectures and coming classes, so we go through these each of these processes in more detail, but this is just to give an idea what main processes there are and what products, what raw materials are used. And to some extent this is of course repetition because we have already gone through a little bit of these different processes and products and raw materials. I will not talk much about the platform chemicals, or not really as I thought originally. Like there is the platform chemicals are usually understood as this important key starting materials that can be converted to various different chemicals. And let's say in biofuel, one could say that D-glucose is a platform chemical because you can convert it to quite many different types of biofuels or chemicals. And there are several, quite many of these important platform chemicals originating from biomass, but when I glance those through today, so majority of them are not really fuels, but those are value-added chemicals used elsewhere in other applications. So therefore those are important and so on, and often they are like the next steps that when we make the fuel or process the biomass, so these platform chemicals are the fuels or the outcomes which are then processed further with other types of reactions and so on. So we will not address that much. But one could say that in this, if we think about that the product is biofuel, so the platform chemicals could be these common monomers or starting materials that we convert into biofuels. So triglyceride, like D-glucose that comes from cellulose or comes from starch, lignin, these different components that are converted further and so on. So overview of some processes. I found this picture or scheme from an article here published in Environmental Chemical Letters, and this has been used as a kind of a system boundary for life cycle assessment evaluations, but I thought that it's kind of good also in connection when we want to get an overview of this biofuel production. And what I like about it is that there are these different like material flows in and what is exiting the phase. Here is the biomass cultivation, then there is the biofuel like production process, and the last is the use of that biofuel, and we have here inputs and outputs in each of these. So I think this gives, at least to me, a good idea or better idea of that bigger picture and problems also that and challenges that we discussed maybe earlier. But if you think about biomass or biofuels, so this is kind of making of the raw material. So we haven't talked much about, but if you grow something, some biomass, so you need often water, you need fertilizers and pesticides. If your crops is let's say sensitive for different pesticides, so that is the problem. So you need inputs already here in the cultivation stage. The diesel is for machinery, tractors and other things that you also probably use sooner or later, latest at least the transportation stage here. So you grow and grow the plants, you collect the crops, and then you have to get that biomass somewhere for that production. And all these inputs generate emissions to air, also emissions to water, and nutrient build up in soil. And then when we talked about sustainability of this first and second and third generation, so this one should consider some things like, this water, pesticide, fertilizers, and emissions to air and water were also considered in these cases. Then once we have the biomass, so it has to be fed into the process. We also often need chemicals, some kind of solvents or additives, or perhaps these catalytic materials. It's not that common that you need to heat up the reactors. Often the reactions do not take place at room temperature. All sorts of process equipment requires electrical energy as well. And very often, like in this, we talk about chemical catalytic conversions, chemical reactions. So it's very typical for this biofuel and not uncommon for other chemical processes that there is the actual chemical conversion or the catalytic reaction which makes the actual product. But in order to maximize it and make it in an optimum way, so there is like upstream processing required, like written here, the biomass treatment. It could be that involves like breaking of the biopolymer into monomers, but it can mean also like removal of impurities, removal of water, some kind of purification steps and so on. Once the material is suited or pre-treated, it enters the chemical conversion, the reactor where the actual reaction takes place. And often it is so that in the reactor, so there is the conversion to products. So we have usually the desired product, the biofuel, but we tend to have side reactions. So what to do with those unwanted products? If in some cases those are problematic, in some cases not. So if those are problematic, one needs to do separation steps, so downstream processing. So you need to purify the biofuel, remove unwanted material. Another thing is that chemical reactions seldom convert 100% to products, so you end up with unreacted starting material. That's also something that you probably want to remove. Maybe you want to recycle it back and react it again and so on. Then same as in the cultivation stage, so you end up producing perhaps emissions to air, wastewater, or perhaps some other waste materials. And the last stage is the use of that biofuel. And then the inputs, of course, are the actual purified and the fuel product itself. Maybe you need some other products, and also the diesel here is like for transporting. So the first stage is to transport the biofuel to the consumers. Not very surprising, but the use and then maybe recycling stage are also included here. But at least I like this scheme, so that it helps maybe to think that it's not only, we very often tend to think that it's biofuel production is, or we easily think that it's only the chemical conversion of sugar into ethanol and nothing else, but the actual production is much more complex, and you cannot simplify it very much, because there are these different steps that when you see it, so those are inevitable, that you have to go through or do it in this way. Then you can approach and categorize these processes in a different way. So here it's based on, if you select based on raw materials. So these graphs you have more or less already seen, but the raw materials coming from cellulosic biomass, so those can be gasified. You'll make the synthesis gas. This is something that we deal in the coming lectures, but the synthesis gas is very useful mixture. So there is the carbon source, there is the hydrogen source, and with proper catalysis and reactors, you can convert it to useful hydrocarbon products. And like here, you can make alkenes. Those are hydrocarbons, so work as a fuel. Alcohols, methanol, and hydrogen all can be used as fuels, or these can be also processed further to something useful. Then we can use pyrolysis or liquefaction. These are also part of the process, two processes that we take a look at later on. So you end up with bio-oils. Synthesis gas is fairly easy to purify and simple mixture. Bio-oils are mixture of tens of different hydrocarbons, alcohols, and other chemicals. So those have to be upgraded. So the next step is removal of oxygen with hydrogen to get some liquid fuel components. These are not specified because it's again quite complicated mixture. Or here you'll see this zeolite word coming, maybe not first time, but you'll see that these zeolites can be used also to upgrade these bio-oils into, so improve their properties, that they'll function better as fuels. Then the third common route from cellulosic biomass is this hydrolysis route, and this means hydro in this refers in principle to water, so breaking with water the polymeric structure, or chemically it means that from that cellulosic chain you break these ether linkages, these 1,4 linkages, glucosidic bonds, by adding into each bond a water molecule. So therefore it's hydro refers to water and lysis refers to breaking. So you break the bonds with water, at least. Of course, you need a catalyst or enzyme to do the job, but That's the name explained. And there are various methods that you can then convert this hydrolyzed material into products. So you end up with sugars, so you can ferment them into ethanol. That's something that we take a look later. You can dehydrate, so remove hydrogen and make aromatic hydrocarbons. You can do so-called aqueous phase processing. That's one type of reaction that converts chemically sugars into hydrocarbons. I think that we will also, there is a small section or chapter in that course textbook about this aqueous phase processing. And also from that biomass, you end up with that lignin, which was not sugar-based, but this aromatic 3D matrix. And there are possibilities for lignin upgrading, not only one, but I think several, at least nowadays. And you can also convert those into gasoline type components. So that was the one graph. I also wanted to include here another type of raw material which is not covered by these processes or these reactions, is triglycerides. So those were these fats and oils which has the same triglyceride structure. So natural oils, natural fats coming from animals, coming from vegetables, plants. And two possibilities that we cover during the course is the FAME production, fatty acid methyl ester. So we take alcohol and use acid or base catalyst, and esterification reaction makes that product. Also the glycerol comes as a side product, but we'll get this biodiesel out from that. Then there is the more advanced process, this HDO, hydrodeoxygenation, where removal of oxygen functionalities from those same type of triglycerides. And then we get this better quality HVO, hydrogenated, hydrotreated vegetable oil, diesel, for example. So these cover majority of these reactions and processes. Of course, there are then variations how these are done with different reactors, different conditions, different catalysts, and so on. So this is not, we don't have only 5 possibilities to process these two types of raw materials. One can also, I copied here from different sources this kind of schemes and figures. So here you can also think about what other types of raw materials. So these were like the chemical structures. So triglyceride and cellulosic material, that's more on the molecular level. These are more on the, let's say, origin of where it comes from, the plant type. So here is like food crops, edible oils, here energy crops, waste materials, then some animal microalgae, waste cooking oils, and also other raw materials. These 3rd and 4th generation biofuels are not that well clarified or defined, but these 1st and 2nd are quite clear. So first is edible crops, and 2nd generation is non-edible ones. So here are more like the actual starting materials: potato, wheat, palm oil, etc. Here the energy crops these are plants that are not used for human or animal nutrition, but these usually grow very fast and efficiently and have composition that can be quite easily converted into fuels, or at least fuels. Waste products are one type of important field where developments are taking place. So instead of using these edible or virgin materials, so it's important to try to increase the use of waste to make some kind of useful products out from it. This is again similar things put in a different graph, so and from the different source. So these start to kind of repeat each other. Some graphs are missing certain things, some not, and so on. But here is like grouped something based on these generations that we already saw in this previous picture, but it's more on like what type of starting material, and then here is the little bit more about the process alternatives. So sugarcane extraction, making sucrose, here's fermentation, you will get diluted aqueous ethanol solutions. You need to distill it so that you can get water-free ethanol that can work as a biofuel. This second generation, so the products are, well, it's here there are different methods grouped together, but biomass through pre-treatment, you get sugars, you ferment it, get ethanol. Of course, you can pre-treat biomass to gasification and you get, well, synthesis gas, or you can make hydrogen, or you can make methanol, what we had in that first slide. You can also do different types of pre-treatments. We cover those, I think, next week, at least some alternatives. So enzymatic hydrolysis is also can be understood as pre-treatment. So then it can produce feed into all of these three alternatives listed here. Here the third generation is microalgae. Let's say, was it here? Here is also microalgae, waste cooking oil. I would say, now that I look at the waste cooking oil, in my opinion, it should be maybe more in the second generation waste products category. But there are variations, as I said. Pre-treatment, extraction, transesterification, and fatty acid methyl ester. Here is, so this is the, from microalgae, you remember that there were both these lignocellulosic components and those fats and lipids. So this upper one is for the lipid, so fats and oils. The lower one, saccharification, refers to the sugar-based materials that are fermented to alcohol. Often it's fermentation to ethanol. And the fourth generation here is, well, energy crops, algae, biomass, and so on, with techniques treated with pyrolysis or gasification or some digestion to make basically biofuels. Here, hydrogen, methanol, and synthetic biofuel. This is not, I think, if you want to make synthetic biofuels, so this is very simplified representation of that process. But But in any case, products-wise, I found this from also one source. So here, if we look at again this first to fourth generation processes, so just what products can be made out from it. So by alcohols, diesel, biogas. Biogas is not part of this course. It will be in the next waste to fuels course. But here is also second generation. So the products are the same alcohols as here, but the production route or process is different. Then synthetic natural gas, that's also very close to biogas, and dimethyl furan. Here is listed biodiesel, new, maybe butanol, that has not come up in very often, but it's a good, like mentioned in the earlier lectures. So butanol is very good alcohol. It's very close to gasoline when it comes to properties. Here's also propanol, slightly longer chain alcohol than ethanol. Yeah. Here we see the same. It's, I think, the prefix bio in it doesn't mean much that it's from biomass origin, but the actual chemicals, like talked already, so those are the same. Butanol is butanol and biobutanol is butanol. So there is also biohydrogen is the same hydrogen in practice. Here you'll see similar charts. Again, here the difference is basically now there is focus on the treatment methods a little bit, or the focus is there. So here are different production methods like liquefaction, that is in that bio oil, gasification of biomass, pyrolysis, and combustion. And here is mentioned in that course textbook, this pyrolysis and liquefaction are treated in the same section, and there when we talk about these fuels, so the desired product is more these bio oils, the liquid fractions, not the solid carbon, the biochar. But here fuel gas is also similar or more or less the same as the synthesis gas. So here it's the carbon monoxide hydrogen mixture, and that you can upgrade with, for example, Fischer-Tropsch to these different hydrocarbons that are listed here. But it's difficult to find, like, I have gone through quite many articles and trying to find picture that would incorporate most of these things into one and the same picture, but that's not, I haven't found a good one yet. So therefore I thought that I'll show these different alternatives and maybe the varying angle how to approach this on a general level, this biofuel production processes. These are boring tables to present, but I'll incorporate this because this have a very useful information, and here in this table you'll see the different biomass conversion technologies. So these are, we have been talking about different processes. So here you'll see the method. So there are different pyrolysis techniques on this graph, or sorry, this table. You'll see what type of fuels come out. So in majority of these, regardless of it is flash pyrolysis or catalytic co-pyrolysis, so you tend to get some bio oils or liquid products. In this one, you'll have biochar, so that's the solid carbon-based material. Here are also interesting additional details regarding the process, so composition, yield, efficiency, and so on. Also the experimental conditions, so the temperature, pressure, and such that have been used in that processing. So we talk about pyrolysis, so at least one could note that the temperatures tend to be quite high. So 800, 600, 500 degrees Celsius, and so on. Then if we take a look at this table was really long, so I had to split the same table into different parts to be able to. These are now like these were more or less pyrolysis, and the product is bio oils. So then we get the product is biodiesel in all of these at least. And here you'll see different production methods. So it's main thing is the transesterification, which is the chemical reaction, but then here is some additional information about alkaline, so base catalyzed. Here is something called single step transesterification. I'm not sure what is meant by it. If I want to know more, so one should go into this article and check the reference where the data is taken. Also here are like different feedstock types. So waste cooking oil, animal fat, I don't know what is this, different oils, waste oils, and so on. And this is acid catalyzed transesterification. So there is acid and base. I don't know, maybe it's done in 2 stages. So there can be first acid catalyzed and then base catalyzed, but they cannot work in the same time because they would neutralize each other. Microwave assisted transesterification. Microwave techniques are used for heating purposes, so it's a unconventional or non-conventional way of heating the reaction mixture. And sometimes microwave can also have enhance the reaction or selectivity, but this is an enzymatic reaction, and here is non-catalytic transesterification and reesterification and transesterification. So these are like real, let's say, processes, and just to give you an idea that the situation is not so simple as these graphs or schemes are showing. Then the table still continues, and here are alcoholic fermentation is the main method. Products are these alcohols. Here you get this is not fermentation, it's anaerobic digestion, so that's making of biogas. That's totally different. One should maybe cut the table part out. But here are basically, if we take a look at this bioethanol product, processes are roughly similar, but the feedstocks can vary. Sugarcane molasses, date palm waste, kitchen waste, or that's the biogas, microalgae, date molasses. Then now the table and the source changed, but these are now in addition to, we had like bioethanol, biodiesel, and bio-oil, and these are not from the same publication, but these are other types of processes. And this also comes from a quite recent article. So here, I think it's a good collection of these commercial or pilot scale processes that can be found at the moment. So there's the company or institution behind of these. Here is feedstock composition. So what you see here, wood waste, synthesis gas from gasifier, dry wood chips from recycled wood, forestry residue, clean wood, waste wood, synthesis gas from a gasifier, and so on. And the products that you obtain, so this renewable diesel, so that we haven't seen yet. So this HVO, you also have in some cases the technology. This refers to, at least this refers to the specific reactor, fluidized bed gasifier. Here are also what we didn't encounter earlier is Fischer-Tropsch liquids, and Fischer-Tropsch liquids. This is the process that we take a look in detail later, but it uses the synthesis gas, so mixture of carbon monoxide and hydrogen to make hydrocarbon products. Then this is also large table, and this is the second part of it. So feedstock composition. So here is also forest waste and crops residue and such. Here are also this kind of leftover waste materials like hazelnut shell, olive cake, wood chips, lignite blends, residue from wood residue, wood chips, refuse derived fuel that I'm not familiar with, and some waste material. And the processes or products also are Fischer-Tropsch liquids, jet fuel, synthetic natural gas, methanol, and diesel hydrocarbons. But also this table tells, if you see the starting year, and I don't know if you are familiar with this TRL, so it's technology readiness level. And the higher it is, so closer it is to real commercial operation. And you'll see here that TRL9 is the commercial operation. These in middle are some kind of pilot pilot stage experiments or runs. And pilot stage can also mean quite different things depending on the field and industry. So I think when we talk about these fuels, so the pilot is, well, here are these production amounts, so 60 tons per year. So that's a pilot stage, and it's like 250 tons a year, and it's a pilot. So we are talking about several tens or hundreds of tons of material. So that's typical for pilot scale volumes in, let's say, this fuel industry. Pilot scale in some other, like food industry or pharmaceutical industry, could be like few hundreds or maybe few tons per year also can be called a pilot. But in contrast to this commercial production TRL9, so contra to 250 tons a year, so here is like, this is 300,000 tons a year, if I read it correctly. So it's 1,000 multiplied by 1,000. So from that pilot volumes to this commercial. It's not, this TRL is not only about the volumes, it's about like, is it how the technology is run, and is it like a pilot or lab scale experiment or test and so on. It tells, and when it goes to this TRL below 1, 2, and 3, so it's more like proof of concept or making it in laboratory scale, so in quite small volumes. But I started to talk about this, so that these tables, what I find interesting is that these are fairly recent, and these maybe tell you something about the developments that are taking place. So a few years back, so there are quite many piloting and some commercial stage production sites already running. And I think this list is just taken from one article, and certainly there are, I think this is not a fully complete list what exists. This is the last slide, again taken from another article, and this is something that combines very many of those processes that we covered, but it's very difficult to read. Here is like feedstock supply volume, so you'll notice this arrow that here it's low supply volume, here it's high supply volume at the lower part. This other arrow here shows that what is technology-wise more challenging and less challenging. So these on the upper part are less challenging technologies. So transesterification, here is isomerization, NextBTL biodiesel. This is that Neste company's technology that they make this HVO diesel. It was previous, the process is called NextBTL, or this comes from the words next generation biomass to liquid. What, I don't know if we can find anything new in here. It's probably the main things: transesterification, fermentation. Here we see the synthesis gas route when we get ethanol, hydrocarbons for diesel and gasoline, and also can get alcohols. Here this is the type of catalyst that we discussed. So mixed higher alcohols from synthesis gas. So can be with this sulfide catalyst that very also similar used in the removal of sulfur. Here it's not due to sulfur removal, it seems to do the job in order to make alcohols. And also if you notice that this solid box around refers to commercial level technology, dotted lines emerging, and these less loose, or how to describe it's developing technology. So one could say that here the isomerization is emerging, transesterification commercial, fermentation already commercial. Here acid dehydration of cellulose is emerging, and so on. But now I have only the last slide left. So just to summarize, so I don't know, was this of much use, but I wanted to give you some different angles how to approach these biofuel production processes. So approach from the technology or the product or raw material point of view, and so on. But coming back to this, so we go in the coming classes or lectures to focus in basically more or less all of these in more detail still. Now we have this bigger overall picture, so later on we start to look at smaller details to get in-depth idea how these different processing steps are done. And again, these are just describing the chemical reaction steps. So in many of these, there are purification steps, downstream processing, and also different upstream processing and pre-treatment steps taking place.